Our first speaker then is Dr. Flavia H. Santos. She is a UCD Ad Astra Research Fellow here at the Geary Institute for Public Policy and an Assistant Professor at the School of Psychology. She's currently the Principal Investigator of the Artemis Project funded by the Irish Research Council. She's an active researcher at UCD Affective Behavioural and Cognitive Neuroscience Centre, developing innovative translational research on neurodevelopmental disorders. She's mainly focused on numerical cognition development and factors that affect its functioning, such as maths anxiety. Flavia has a strong interest in how emotion and cognition interact through music science. She's carried out studies on interventions to stimulate and remediate mathematical performance using musical training and computerized tasks. At the School of Psychology, she leads the UCD Music and Math Cognition Lab and is also a member of the UCD Childhood and Human Developmental Research Centre. She has several peer-reviewed articles in neuroscience. Also, she authored and edited 8 books in the field of neuropsychology and rehabilitation. Dr. Santos is the chair-elect of the Mathematical Cognition and Learning Society. Congratulations. And today she's going to talk to us about unveiling the role of maths anxiety and the interplay between beliefs and attitudes towards math and career choice.
So, hello everyone, good morning, and welcome to Sustaining Accessibility in Mathematics. It's a great pleasure to be here today. So, I'm Dr. Flavia Santos, and I will present the work Unveiling the Role of Maths Anxiety on the Interplay between Beliefs, Attitudes towards Maths, and Career Choice. This work is a team effort, so I would like to say that who is leading this project is Dr. Mariusz Gomides, which is the postdoctoral researcher in our lab. It started with a master thesis of Claire Elliott, and then we have collaborators from different universities. Dr. Sara Caviola from University of Padova in Italy, and Dr. Christoph Chipra from Loughborough University. So the outline of this talk is this. So we will discuss first the impact of maths anxiety and low self-efficacy on maths performance. Then I will present the research we carry out. And after that, I will put some insights from the Artemis project, which I believe fit very well the moment. So I would like to start talking about this policy paper, which was published on the Geary Institute. So the title is very clear. So it says, a child with maths anxiety might become a parent or a teacher with maths anxiety. It means that when they become adults and they are trying to teach other kids, they might express their own feelings, remembering or reviving their feelings about mathematics, and that will lead to influence the way the kids will learn mathematics. And then it keeps going as an intergenerational process. So how can we conceptualize maths anxiety? So it's a feeling of tension that interferes with manipulation of numbers and solving maths problems. And that's very important to say that, of course, we will see it in academic life, but more importantly, in ordinary life as well. So we are talking about a child that might struggle in classroom, but perhaps when they are on the holidays trying to just get the change for an ice cream that they are buying, they will be tense about it. So this feeling of tension and apprehension towards maths is weakly correlated to intelligence. So that's a very important thing to know, because usually when you see a child with a low grade, the first thing to think is, this child doesn't know much. So it's very important to understand that even among the high achievers, even people who actually in mathematics received gold field medals, which is the most important medal in mathematics, equivalent to a Nobel Prize, even those individuals, when interviewed, they reported experiences of some sort of anxiety. Maths anxiety nowadays is considered a form of a specific phobia. So it means that the fear of mathematics is actually equivalent to the fear of spiders, for instance. So this is something that we need to bear in mind. And maths anxiety is not, for the moment, a diagnosis in ICD-11 or the DSM-5, but we know that it's a question of time. It probably will happen. And what I'm telling you, why I'm telling you that, why is this important, it will influence the way we offer treatment. And we, after investigating a lot about this, we know that there is a very important component which is cultural. So sometimes if you change the culture, maybe you can solve the problem, or at least part of the problem, or the mild cases. So that's an important aspect. So what are the symptoms of maths anxiety? So nowadays we say that it's multidimensional, which means that you have first physiological symptoms like shaking, sweating, heart racing, butterflies in the stomach, but also have one component which is cognitive. So, which is the one which is very important for learning, because if you cannot focus on, if you cannot put your attention on what you are trying to do, then it will be disruptive. So the child is trying to do 3 times 3, and instead of thinking of numbers and the relationship between the symbols and the numbers, they are thinking, oh, what if the teacher asked me to answer that? What if I don't know the answer? So those feelings will be really, really impacting their performance. And another dimension is behavioral, which will be the cause of avoidance behaviors. So the child will try to not do nothing related to maths, to exactly not have this uncomfortable feeling, which is the last dimension, the feelings. So the fear, or sometimes disguised in anger or contempt, and so on. Another thing that's very important to say is that maths anxiety is a global phenomenon, okay? So it means that we are seeing this everywhere. So according to the PISA, which is the program for international students assessment, we know that, I will spend some time in this image, we know that if you're looking at this graph, which has the representation of 63 countries, and we will see very interesting and very important trends. So first of all, you see that on the left side, you see here more European countries like Netherlands, Finland, Germany, etc. In the right side, you see more countries like Thailand, Tunisia, Brazil, etc. And the graph is about, on the y-axis, mathematics scores, on the horizontal axis, maths anxiety. So what we see here is that in developed countries, you see, let's say, less maths anxiety in comparison to developing countries. But it suggests that we have problems related to poverty, and not just lack of money, but all the other consequences related to lack of money, including cultural perspectives, but also access to resources, access to learning opportunities, and so on. And if you are curious, of course, I put the flag here so you can see where is Ireland. But what I want to highlight as well is that if you look at the top, you see here basically Asian countries like Japan, Korea, China, and Singapore. And even if you're looking at China in different areas, you see Shanghai, Hong Kong, Taipei, and Macau. And what's important, this is the group with the highest scores in mathematics. And even among them, you see also the presence of maths anxiety. So like I was saying before, even high achievers will have maths anxiety. And the last thing to say about this graphic is that it's a plot from the PISA of 2012. So it means that the students had 15 years old at that time, and today, 2023, they will be completing 26 years, which means that they are active individuals in the society, which will be trying to pursue their careers and also trying to raise their kids. So that's the point. The recent edition of PISA, instead of using, again, the scale of maths anxiety, this time they use a measurement of growth mindset. So here I selected 2 questions only, and in which you can see the responses of Irish students in contrast to OECD average scores. And so Ireland is in the red. So what we see in the last question, in the 2 questions in the right side is, when they fail, they worry about what others will think about them. So it means that 64% of Irish students are more concerned about this in comparison to 56% of the average in all countries. And the last question is, intelligence is something that can't change very much. So 74% of the students in Ireland think in this way. So it means that, oh, if I cannot change that, why bother? Why try harder? So that brings me to another concept that I believe is very important for this talk, which is the concept of maths self-efficacy. So the idea in maths, the idea of self-efficacy is that when you think that you are capable of doing something, you invest your energies to do that. So you will try to do that. So in the case of mathematics, it's precisely this. You have the confidence that you have the ability to successfully perform a maths exercise in a given level, at a given level. I bring here one scale that is the one used by the PISA study, by the way, and the one we used in our research as well. So you have a list of questions in which you can detect this maths self-efficacy. So you can ask, how confident do you feel about calculating how much cheaper a TV would be after a 30% discount? And this graph, I don't want you to be too worried, that's why I did it very small, but here you have only the very confident students. And even among the very confident students, you can see that like less than 60% of them felt confident about calculating the petrol consumption rate of a car. So that's mathematics in everyday life, right? So what we know from research about maths self-efficacy. So first of all, the higher is the maths self-efficacy, the greater will be the persistence in difficult items. So they will keep trying, keep going until they succeed. And because they are trying harder, they will try to find different strategies, they will check the quality of their work, and consequently they will be more accurate in their responses. We also know that maths self-efficacy can predict maths performance in a better way than previous maths experiences. So when we talk about maths self-efficacy, we are actually discussing attitudes towards maths. And those attitudes towards maths could be positive or negative. And of course, we are interested to understand what happened with the negative ones. So students with high maths anxiety, they will show lower levels of engagement and enjoyment in learning mathematics. That's very powerful, okay? They have lower perception of their own ability, and that's one of the things we are measuring today in this talk. They also undervalue maths in its usefulness. So if you don't understand why is it for, why will you invest your time trying to learn it? So as you can see, attitudes towards maths, which is the concept of maths self-efficacy, is something that's very connected with maths anxiety, but which is very intricate, but not necessarily means the same thing. They have, based on this systematic review and meta-analysis by Lee and colleagues from 2021, we know that those concepts are negatively correlated, so the higher is the maths anxiety, the lower is the maths self-efficacy, but they still distant enough to be considered two independent constructs, and that's why we are measuring both in our research. And why is this relevant for us today? So these are plots from the Central Admission Office. So they are the ones related to the Living Certificate. I know that there is in the audience people from abroad, so the Living Certificate is the admission exam done in Ireland, but in other countries we will have a different name to admission at the university. And here, essentially, the students must prove their performances in English and mathematics. So in the left side, you see the graph related to mathematics. So you see on the top, maths H1, on the bottom, maths H08, which means that H1 includes the individuals with 90 or 100% of correct responses in mathematics. And on the other graph, you see the scores in English in the same logic, except that the highest score is on the bottom and the lowest score is on the top. And what we see, going back to the first graphic here on the left, is that the higher is the score in mathematics, the higher is also the likelihood of choose a career in STEM as first choice. And this likelihood is decreasing according to the grades in mathematics. And they are increasing for English, so you can imagine that the next graph is actually below the previous one. So the higher is the score in English, the lower is the likelihood to choose a course in STEM as first choice. So let's see it in words. If you have a person that wants to be a physician, and physician is a STEM career, and if this person has no good grades in mathematics, even being vocational to be a doctor, this person won't be. Okay, so that's very important. I selected this study because I think this is very important, because one thing is admission. Okay, you go to the university, you manage to enter, and then how you deal with that when you are there for the 4 or 5 years of your course. So this study did exactly this. So they measured maths anxiety in the first year of undergraduate students and did a follow-up in some skills. So they were interested to know which courses they would choose to do at the university and the grades in those courses. And they observed that students with high maths anxiety, they chose less courses in STEM. And among those who actually chose courses in STEM, they had lower grades. But I want you to drive your attention to the title, which says, independently of maths ability. So they were competent, but not confident. So this is very important. So in this scenario, here I put a summary of what we discussed so far. So maths anxiety can be a barrier for pursue, progress, and remain in STEM careers. We know that maths anxiety is associated with avoidance behaviors. And of course, if you are avoiding mathematics, your grades tends to be lower. But it's unclear to what extent attitudes towards maths, let's say maths self-efficacy, will mediate those outcomes. So in this study, we actually delved into this question, how maths anxiety affected individuals' prospects in choosing a career in STEM, but we really try to, let's say, triangle this with maths self-efficacy and maths self-confidence. So our study design was cross-sectional. We did just a survey using Qualtrics, and in this survey we had a few questionnaires and also task to perform, and we try to see how participants react to this. We also did a pre-registration, which means that the analysis we are showing you were planned before data collection to avoid biases. And let's see how it goes. So participants initially were 198 Irish and English students, aged 18 to 35 years old, with a median age of 20 years old. We had 18 exclusions, individuals that self-report neurological disorders, clear diagnosis of neurological or psychiatric disorders, and also learning disorders. So individuals that said, yes, I have a disability on calculation, reading, or writing. So we didn't include them because we want to see what is the typical development, so no clinical samples. So as you can see, we also did something else. We divided the individuals into two groups. So STEM and non-STEM, and you use a formal definition of STEM, not just the acronym. So it includes students in the field of mathematics, physics, chemistry, computer science, space science, geology, biology, technology, and engineering. And all individuals from different courses from those options, they were classified as non-STEM. So as you can see, we have a sample that has more non-STEM participants than STEM, and also we see that there were less females than males. This starts to be an important aspect for limitations, which I will not discuss for a limitation of time, but I want you to be aware of it. In terms of instruments, we use one scale for maths anxiety, one scale for maths self-efficacy, the one I showed you before, one scale for trait anxiety just to control, and one scale about procrastination, because procrastination is a very recent concept, but it's also a way of having attitudes towards some goal, like in this case, towards mathematics. So we use to see how it interferes with performance. And we also used two single item questions. One was to understand their liking for maths, because maybe you are not good at maths just because you don't like it. So who knows? So we were trying to understand this. So we had this question: how would you rate your liking for maths from 0 to 10? So I'd like it very much, or I like it very much. It was a slider, so they could fit this in any place. The second question was, what is your maths self-concept? So how would you rate your maths ability? Without doing any examination, just how would you rate it? So they would say, oh, it's very bad, or it's very good, or anything in the between. We know that sometimes individuals can say, yeah, I'm very bad. But then when you ask them to do some tasks, yes, they actually know something about maths. So because of that, we believe that it was very important to have an objective measure of maths performance. So we had this arithmetic fluency task, which is only 2 minutes to perform, between 40 items, single and multi-digit. These are a few examples you see on the right side. So the person must perform this in the fixed order without skipping items, and that's how you measure fluency, because some people will be faster and some people will be doing this more slowly and get less points. As for descriptive analysis, so for all the measurements I told you so far, so again, STEM versus non-STEM, and those squares representing statistical differences. So what we see is a clear pattern. So students from STEM, they had a higher liking for maths, which is natural. They had a higher maths self-confidence, so they were thinking they were capable of doing maths. They also had higher maths fluency, so actually the real performance in mathematics was better, and they had better self-efficacy. By contrast, the non-STEM group had higher maths anxiety, and by higher I say very high, note the scores, higher trait anxiety, and higher indexes of procrastination. Bear in mind that it's a self-enrollment research, so we couldn't balance groups or nothing. It's just spontaneous people participating. So again, like I was saying before, we don't have the time to discuss limitations, but this is perhaps something to consider. So we had different statistical models. I will skip this slide because we waste a few moments at the beginning. But I think you're looking at this, it's sufficient to understand. So we had 4 models. This is the model 1. And we are trying to see in this model the association between career choice and maths anxiety. So in this case, we had 5 predictors, which are the ones you see on the table. So maths fluency, maths self-efficacy, trait anxiety, sex, and maths anxiety. Sex, because we know that gender is something that influences performances in mathematics. So this is perhaps the most important finding at this talk. So we observed that only maths self-efficacy was determining career choice. So this is very important because we are all the time talking about maths anxiety, and you don't see maths anxiety as being significant here. So that's an important finding. And the model explains 45% of the variance, and also was able to classify individuals, the cases, in 87% of the cases. Then for the model 2, like I told you before, we are trying to understand which variables could explain why a person would have a liking for maths or disliking for maths. So if looking at the graph, we see the key finding is clear, so individuals in STEM like maths most. But when we're looking at the model, so what explains this preference or something like that, we see 3 variables which are important. So let's start with the negative beta. So the higher was the maths anxiety, the lower was the liking for maths. So definitely this is important. But also we see that individuals with high maths fluency and high maths self-efficacy, they actually liked mathematics more than the other students. And this model is explained 75% of the variance in this liking for maths. The third model is about the self-concept. So the question was, how would you rate your maths ability? And again, students in STEM area liked it more. And looking at the model, it shows similar trend as the previous. So you see the 3 variables influencing this response. So the higher is the maths anxiety, the lower is the self-confidence for maths, and the higher is the maths fluency and maths self-efficacy, the higher is also the self-confidence in mathematics, in their maths ability. The last model was an attempt to see how maths self-efficacy could mediate the relationship between procrastination and maths fluency. So that's the model we are trying to run. And the results are that indeed maths self-efficacy is an important mediator in this case. In fact, it mediates 57% of the variance on the findings of the relationship between procrastination and maths fluency. And then the key findings of this study are then that maths self-efficacy was the sole significant predictor of career choice. Maths self-efficacy mediates the link between maths fluency and procrastination. Maths anxiety did not predict undergraduates' probability of taking a STEM course. So there's something else that is driving this decision. Maths anxiety predicted maths self-concept and liking for maths, and the interventions, that's now a suggestion only, it's not a conclusion. Interventions should be targeting maths self-efficacy from one side and targeting maths anxiety in the other side. But we need both. So in the last minutes that I have, I would like just to show you insights from the Arithmos project. Arithmos project is a research led by the UCD in collaboration with the TUD, Technological University Dublin, and it's running in my lab, and it's funded by the Irish Research Council. So this project has different outcomes, but we have 3 big ones. So one is an RCT study, a randomized control trial to study and how a digital game, which is the one designed by the TUD, will reduce maths anxiety and improves maths performance. We also developed the teacher's maths classroom management program. And then we create a cartoon video, which I hope to show you. What's the main idea here? If you just address problems of the child, you will not succeed, because the child will go home and see their parents. And if the teacher has maths anxiety, the teacher will be teaching in a way that perhaps is not ideal. So definitely, it's very important to always have everybody involved. So children, parents, teachers and also policymakers, because if you don't change it, it will be very difficult to have better scores in the future. So just to inform you about the teachers' maths anxiety classroom management, we had then this presented in different forums, so I'm very pleased to say that I was invited by Institute of Physics, because physics teachers are also concerned about maths anxiety in students. I had the honor to present in the Maths Meet, which was in the Maths Week, and it was amazing because they had even to change the theater, because there's all teachers from primary school to university, all of them were very interested in this topic, so we really need to make a movement in Ireland to make people more engaged in this topic. I also spoke about this in the Science Foundation Ireland, so in the Curious Minds Facilitator Workshop, and of course in several schools, and including universities, so here for the UCD School of Mathematics and Statistics, but also at the University of Cambridge. And here, just to finish, I would like to mention some of the findings, some of the recommendations I gave on the policy paper I presented at the very beginning, because I think that's important for all of us today. So first, increasing awareness concerning maths anxiety for students, parents, and teachers. Reducing gender and race stereotypes related to maths learning and maths performances. I think we also have models. What is or who is a mathematician? So the image of a mathematician is something that really, really stick, and people say, "Well, I will never be a mathematician because I don't have that prototype, cultural prototype." So that's very important. Reinforcing maths learning supports. We know that UCD has an amazing maths supports for undergraduate students, but my call is let's start with preschoolers, first graders, because then if they like maths, they probably will have less maths anxiety, and then we will pursue a career, and then we will have more mathematicians and people in STEM overall. Other recommendations were to avoid putting students under pressure. This is, of course, especially for first and second graders, because that's the time they should learn how to love maths, not to be afraid of maths. But especially at the universities, it's still important. So we need to see how to do those timed tasks in a way that is good for learning, but not a source of stress. Cultivating motivation to learn maths and confidence in students' abilities in classrooms. So we are talking about math self-efficacy here, and we should go beyond. So growing self-efficacy and resilience in students from disadvantaged contexts. And this is very important because the PISA study showed that students from disadvantaged backgrounds which were high achievers, they explicitly said that they don't think they are going to the university. So we are losing talents. And so providing preparation for the Living Certificate, so helping students to be there, because otherwise they might not get the career they would like to, especially in disadvantaged areas. Equipping teachers with continuous performance and professional development, so like the training I told you before, to learn about maths anxiety, to learn about their own maths anxiety, and offering cognitive and behavioral therapy or other forms of therapies for those with very severe cases of maths anxiety. And the last slide was really the video. So this is the video. It's easy to find on YouTube. You just put there maths anxiety, Rhythmus Project, and Irish Research Council. The link is here, but of course, for seeing it's better this way.
Working with numbers makes some children feel nervous, upset, and even scared. It is like there's a monster in there. Luckily, the monster is not real. It is just your mind telling you to pay attention, be careful, and brave. When you learn how to face the monster, you will also get better at maths. Tell your family or your teacher about the monster. You can also write down what it feels like or talk to a friend. If it appears when no one else is around, during homework or in the classroom, take deep breaths, think of something you're good at, and then go back to your maths exercises. The more you face your monster, the smaller it will get, until even if it does appear, you won't be scared anymore. Math makes everything we do better. Scientists use it to discover new things, and astronauts use it to learn about planets and stars. But other people also use maths in everyday life. Builders use it to build houses. Bus drivers use it to make sure they arrive on time. Doctors use it to prescribe medicine. Chefs use it to plan meals. Athletes use it to train. And musicians use it to write songs. These people were once kids like you. Some had monsters around while doing maths, but they tamed their monster to learn the maths. And guess what? You can too.
Beautiful. So I would like just to say thank you so much for your time, for your interest, and especially for the organizers for this amazing event. Thank you. Bye.